All right, so we've been studying uh, quite a bit of ideas already with quadratics. Remember, a quadratic is really the same as a parabola, any equation that has an x squared. What we want to do today is we want to just kind of pause a little bit, practice, but also extend and start to understand that the concepts that we're studying, they start to all come together. They're not just separate ideas. We've talked about standard form, we've talked about vertex form, and we've even talked about transformations. So let's kind of find out how all these items can start to come together. I'm going to do a couple of the problems on here. I would have done them in the class with the kids. They're the ones that are circled, but then your task is to complete the rest of these. This paper is going to be turned in for a grade. But right now, let's just kind of see what we have learned. What do we need to do here? We need to use a combination of tricks to basically make a sketch. We're going to use a combination of tricks to make a sketch, and apparently we need 5 points labeled on the sketch. Now, don't panic, because just like it says, we have a combination of tricks. One of the things that I see in this first equation is that it's in vertex form. And vertex form makes it really easy to find the vertex, because remember, these two numbers right here basically represent your shift of the vertex. And so I believe that if there's a -2 on the inside, that means we shifted to the right 2. And if there's a +2 on the outside, that means we shifted up 2. So think about it. If you went right 2 and up 2, you should be at 2, 2. You should be at 2, 2. So we'll start with that point as our vertex. What else do we know? What else do we know? We know that this parabola is going to open down. Now I can kind of think about a parabola that opens down just to sort of get my bearings, but I don't know if I want to draw an exact parabola because I need some more points. The idea here was to come up with 5 points, and again, all I have is 1 point. How about the y-intercept? The y-intercept is always found by plugging a 0 into the equation. Do you remember that idea? Yeah, usually plugging in a 0 is not that bad because, well, at least something is equal to 0. We end up with -2 squared. Pardon me, you end up with the opposite of -2 squared. Now be careful, the opposite, or excuse me, you have to do the exponent first. When you do the exponent first, you actually end up with +4, but it's going to be the opposite of +4. So we actually end up with -4 plus 2. Of course, plus this 2 out here. So I'm pretty sure that comes out to -2. So you plug a 0 into the equation very carefully, and you end up with -2 as a y-intercept. Now, remember how that parabola was going to open downwards? I feel like, at this point I can actually draw that parabola because I have at least a point to connect. And I know that the other side of the parabola is going to have to look symmetrical. Symmetrical, that sort of helps me to think of another point. Another point that would be exactly the same distance from this line of symmetry. We're talking about this distance right here. Now this distance right here is a distance of 2, so I have to go 2 more units. 2 more units from this point will give me a symmetry point that's over here at 4 with the same y value for -2. Well, now I feel like I'm cruising because I got 3 points on the parabola. We just need 2 more points. And honestly, as we did on the very first day, we just need some points that are around the vertex. What do I mean around the vertex? Well, the vertex is at 3, or excuse me, the vertex is at 2, so that means that I want to go a little greater than the vertex. How about 3? Okay, now I didn't just pick 3 randomly because 3 is the next number that's greater than 2. But what I do want to do is I want to very carefully plug in 3. And when I plug in 3, I'm talking about plugging it in for x. All right, so well, you plug in 3. I believe if you subtract those numbers, you end up with 1. Of course, it's the opposite of 1 squared. Now remember, you want to do the exponent first, so that's going to actually come out to be 1. But I got this negative sign that's been floating around, so I actually end up with -1 plus this 2. If you do that carefully, we end up with 1. So when you plug in 3, you get 1. And the whole idea here is that you can use symmetry to find a point over here. Of course, symmetry implies that you're the same distance. Now the distance that we're talking about has changed. Now it's the distance between 2 and 3. That distance is 1. That means I need to go backwards 1. If I go back 1 more, that'll put me at 1. Now I'm talking about the x value of 1 because, again, I went backwards by 1 from that number 2 that you see there. Okay, the y value is going to be the same as this y value, so we have the 0.11. So we used a combination of tricks. We got ourselves a parabola. Remember, we started with the vertex. The vertex perhaps still might be the most important point. We used shifting to come up with that vertex, but after we found that vertex, we kind of went to town thinking about some other points of symmetry, etc. So, yeah, I mean, now that I have my graph correct, it's pretty easy to identify that the graph opens down. It's a maximum. The maximum is the vertex. So I just kind of want you to notice that there's a maximum up there. Looks like we've got the domain to kind of come back and think about. Remember, the domain of any parabola is all real numbers, but the range based on the vertex is, of course, going down. Make sure that you identify it's going down from the y value of 2. So I've got a range that I can describe from negative infinity to 2. And then what about the roots? We haven't really talked about the roots in a little while. We will come back to that idea in a big way. But the roots are actually these points on the x-axis. I don't know exactly what they are. That's okay, but I do see that there's 2 of them. Let's skip down to writing a quadratic, writing an equation for a parabola. And yeah, I mean, we've got this formula here, this sort of this template, so to speak. It seems a little bit intimidating, but basically it's got the vertex numbers. Remember, the vertex is h and k, and then it looks like we just have like a coefficient that is the letter a. So honestly, what this boils down to is trying to use the vertex as our, if you will, starting point. Again, that vertex, that it really is the most important point on a parabola. So we're going to use that vertex as one of our key points when it comes to plugging in to this template. So, you know, we're going to definitely have the y equals. You're going to realize that we don't know what the a value is, so I really can't plug anything in there. But here comes this vertex in a big way. Because the graph shifted to the right 1, I'm going to be able to use a -1, definitely a -1 right there on the inside. And then because the parabola shifted down 6 units, I can put a -6 on the outside. Well, that's looking a lot like an equation. And notice that the vertex played a key part in that. Okay, so we always start the problem with the vertex. Now, the next problem, the next thing to realize is that we need to find the a value. Now, the way that you find the a value is realizing that you're going to need another point. You're going to need another point that you can plug into this parabola. Now, you can use any point, but as you can see here, I'm picking a point that I'm sure of. I'm sure that that's the point 3, -2. Now, what am I going to do with 3, -2? I'm going to plug it in. I'm going to plug it in for x and y. Now, check this out. If you plug in for x and y, you end up with -2 equaling a times, now here it comes, I'm going to plug 3 in for x, so I get 3 plugged in for x. The rest of the numbers come along, that is the -1 and the -6, and I got myself an equation that I'm going to be able to solve for a. Yeah, it's exactly what I'm going to do here. I'm going to solve this equation for a. All I got to do is the order of operations very carefully. I'm pretty sure that on the inside of this, 3 minus 1 is 2, and 2 squared is 4. So that 4 that I got, honestly, I can put that, in front of my letter A. It's just normally the way that we write it, right? We normally write it as 4A, but I'm just a hop, skip, and a jump here. I got to add 6 to both sides. Of course, when you add 6 to both sides, you actually get 4. And if 4 is equal to 4A, then I'm pretty sure that A equals 1. Now, we want to understand that our equation has to be sort of like a final answer type equation where we substitute in, we show the numbers that we got. So we got 1 for A. I still found my H and K values, and I got myself an equation in the form of y equals x minus 1 squared minus 6. By the way, this little 1 out front, it doesn't have to be there. Of course, if it was another number, then we would want to show that. Uh-oh, standard form. Standard form. Oh, you mean you want me to multiply out, basically to kind of simplify out x minus 1 squared minus 6. Yeah, that's what we're looking at. You want to be able to take this equation and kind of expand it. Now remember, this implies the FOIL method, so you're going to be multiplying 4 things together. When you multiply those 4 things together, you're going to get an x squared, you're going to get a minus x, and another minus x, which is minus 2x, and you're going to get a plus 1. Don't forget the minus 6 at the end. So if I expand this thing out, I have what appears to be a different form of the equation, and that it's a different form, but what you want to realize is that it's still the same parabola. It's still the same equation. So we've got y equals x squared minus 2x. When you combine the numbers at the end, you end up with minus 5. Let's look at the back. I don't know if I really have anything circled back here, but it looks like you're going to do a little matching activity. Now, when you match these, you should be able to use the vertex. Again, the vertex is one of the key ways that we understand a lot of things about a parabola. So I know that the vertex is at -2, 1. The parabola has a positive a value, so it should be opening up. And I think if you go over here, you'll be able to find a parabola that meets that criteria. Again, it opens up and it has the vertex. So you can do a little matching with that. I guess we pretty much did it, but you can put the number 1 into that spot. And in this chart down here, is there anything we really need to talk about on this? I don't know. What do you want to talk about? How about we do something in the last box? What we're trying to do here is kind of fill in what we know about this parabola. If it's shifted to the right 1 and up 3, it's not a trick question. That means that the vertex should be at 1, 3. And if I want to write an equation for that, it's kind of like what we just did on the front of the paper. It looks like it's got a compression factor of 1/2. I know that's going to go in the front. I shifted to the right, so it's a minus sign, and it's shifted up, so it's a plus sign. So, all right, we got that filled in. And then, yeah, I want you to do this review question where we kind of go back to the first day, thinking about the opposite of b over 2a, in particular as a formula that will help you with the vertex. But I'm going to let you do that. Looks like I want you to find 3 points on your sketch, so just 3 points. All right, so that should get you ready to rock and roll on the rest of these problems.